Good morning to Dr. Siti Khadijah and fellow friends. We are from Group A Construction Technology BJTC2023. Today, our group will presenting about Petronas Twin Towers. Firstly, let me introduce our members in this group. Our group leader is Fazliyatul Aina binti Md.Fadzil with the metric number 298530. Second is me, Bill Alexzander Anak with the metric number 298331. Third is Akash Moni Anak Osil Kumar with the metric number 298362. Fourth is Yap Lee Ling with the metric number 298797. And lastly, Wong Zhi Kei with the metric number 299155. Next is table of content. Firstly, we will know the introduction of Petronas Twin Tower. Second, Lee Ling will present the detail of the material used in the concrete of the Petronas Twin Tower. Third is Aina will represent about the specific properties that were critical for the construction of Petronas Twin Tower. Fourth is Wong will present the production and construction process and detail the mixing, placing, curing and other construction techniques used for the concrete in the building and challenge faced during construction related to concrete and how they were overcome. Fifth is Akash will present about test of concrete and testing method used during the construction of Petronas Twin Tower. Sixth is Wong will present again architectural significance and specific uses of concrete in the structure and any innovative concrete technology employed in the building. Lastly, conclusion by me. Now, let's focus to the introduction. After 6 years of development, the Petronas Twin Towers in Kuala Lumpur, Malaysia were finished in 1998. Malaysia then Prime Minister Mahathir Mohamad had the idea for this famous building, which were designed by Chester Pelly and colleges at Skidmore, Owings and Merrill to represent the nation's modernity and economic growth. Up until 2004, this structure, which measured 451.9 meters or 1483 feet, were the tallest in the entire world. Built mostly of steel and reinforced concrete, both towers have 88 stories above ground and a unique double-decker sky bridge that connect them at floor 41 and 42. The tower design reflects Malaysia's cultural history by incorporating features of Islamic architecture because of the tower enormous height, which is 451.9 meters or 1483 feet, and the requirement to withstand substantial structural loads. High strength concrete was essential. To attain the desired strength and durability, a carefully balanced mixture of cement aggregates such as gravel, waters and frequent admixture chemical additive. It's used to make this concrete. Super plasticizer and air training agents are examples of admixture that were probably used to improve workability, lower the water content and increase the durability and strength of the concrete.
In Malaysia, high-strength concrete was originally specified for the Petronas Twin Tower. The core structure of each of the tower is composed of a ring of cylindrical column of high-strength reinforced concrete. The use of concrete can prevent the strength of the building from being attacked by heavy wind and can reduce the vibration within the tower. Type of aggregate used in common concrete is fine and coarse aggregate. Size of coarse aggregate used for the Petronas Twin Tower is 20 mm, where the size of fine aggregate used is typically maximum size of 4.75 mm. Type of coarse aggregate used for the Petronas Twin Tower is crushed granite, whereas the type of fine aggregate used is sand. Water is the most ingredient used in concrete mix for the Petronas Twin Tower. The water content used in column 1 is 134 liters, where the column 2 is 154 liters. Typically, the proportion of water cover ratio is 0.4 to 0.5 used in concrete mix for the Petronas Twin Tower. Furthermore, the type of admixture used in common concrete for the Petronas Twin Tower is super plasticizer and water reducer. The type of super plasticizer used in concrete mix for the Petronas Twin Tower is Review 1000, whereas the type of water reducer utilized is Pozzolin 300. And for the Klcc tower project, the percentage of super plasticizer is 0.2 to 0.3%, whereas the percentage of water reducer is 0.2 to 1.8% for the Petronas Twin Tower.
The specific properties that were critical for the construction of Petronas Twin Tower is physical properties, which is density and porosity. Physical characteristics like density and porosity were essential for building the Petronas Tower in order to provide the mass and stability required to withstand dynamic loads such as wind and seismic forces. High physical density material were crucial. The tower's concrete, which had a density of about 2,400 kg, was strong enough to hold the structures while also providing enough weight. Besides, it was 120 meters or 400 feet deep down under the ground. In order to avoid water infiltration, which may corrode steel reinforcement and jeopardize the structural integrity, low porosity was equally crucial. Reduced porosity, high-performance concrete was utilized to increase the building lifetime and durability. Next is mechanical properties, which is compressive strength, tensile strength, and modulus of elasticity. The tremendous weight and dynamic load places on the tower depended heavily on the mechanical qualities of the material. For the concrete to handle the massive vertical load required in the foundation and core, it had to have a high compressive strength. Compressive strength of the concrete utilized were as high as 80 megapascal. High tensile strength, typically between 450 and 550 megapascal, was required for the structural steel in order to withstand the tensile forces imposed by the wind and other lateral stresses. Another consideration was the modulus of elasticity, with steel having a modulus of 200 gigapascal and concrete around 30 gigapascal. This guaranteed the integrity and serviceability of the towers by ensuring the material could endure deformation under load without suffering substantial structural damage. Lastly is durability factors, which is resistant to environmental challenges. For the Petronas Tower, durability elements including resilience to environmental stresses were crucial. Kuala Lumpur tropical climate, with its high humidity and frequent rainfall, called for material that could resist this element without degrading. Admixture to lower porosity and improved resistance to chloride ion penetration were added to the concrete mix to stop the steel reinforcement from corroding. Maintaining the building structural lifespan and aesthetic appeal requires superior corrosion resistance from stainless steel cladding on the exterior. Another important factor was fire resistance. To keep structural steel safe during high temperature situations, it is covered with intumescent fireproofing compound. Even though Kuala Lumpur is not a seismically active city, the design incorporates strong resistant measures like a strong core and deep pile foundation to maintain stability against potential ground movement, even though not in a high seismic zone.
I will discuss the construction technique and challenge faced during the building of iconic Petronas Twin Tower in Kuala Lumpur. Starting with the foundations work, this phase was crucial due to the difficult ground conditions. We installed 104 concrete piles ranging from 60 to 114 meters in depth to ensure stability. This phase, completed by battery solid tank in 12 months, provide a robust base for superstructure. Moving on to superstructures, the towers features a reinforced concrete core wall systems and exterior columns. The floor framing system used composite steel framing with metal decks, which enhance strength and stability. The tower tapering profile was achieved through 5 step backs, maintaining vertical alignment and giving the towers with distinctive look. High-performance concrete was essential with a compressive strength of up to 80 megapascal. This concrete was pumped directly to the 88th floor, requiring meticulous planning and quality control to maintain its property. Several innovations techniques ensure structural integrity and efficiency. These include a cast-in-place perimeters frames with 60 columns, a concrete core for added stiffness, and outrigger beams at mid-height for extra support. We've used a high-strength concrete mix with OPC, micro, silica, and PFA to achieve a target strength for 100 megapascal. We face significant challenge, particularly with the availability of high-strength concrete. We overcame this by establishing on-site concrete plants with a robust QA or QC programs. Temperature control was also critical. We used industrial water and curing aggregates to prevent temper cracking. One of the most remarkable feats was the largest concrete pour in Malaysia's history, spanning 54 hours continuously for each tower. We monitor temperature and strength extensively with 100 gauge on 6th floor to ensure structural integrity. This strategy and innovation technique were crucial in successfully constructing the Petronas Twin Towers, a symbol of modern engineering excellence.
Hi everyone, now I will be discussing the testing of concrete used in the construction of the Petronas Twin Towers. The quality, strength and durability of the concrete were assured through various rigorous testing methods, which I will be explaining in detail. First, we have the slump test. The purpose of this test was to assess the workability of the concrete. During construction, this test was conducted regularly on site to ensure the concrete had the proper consistency for effective placement and compaction. This was crucial to meet the high strength requirements of the towers. So the next one is compressive strength test. This test aimed to verify the concrete strength. Concrete samples were molded into cylinders and cubes, hardened and then compressed until failure. This test ensured that the concrete could support the massive vertical loads of the structure, achieving strength up to 80 megapascal. So the third one is non-destructive testing methods, which is NDT, such as ultrasonic pulse velocity, which is UPV test. It assessed internal quality without causing damage. UPV tests were crucial in detecting voids or cracks, maintaining structural integrity by identifying and addressing defects early. And another important method was rebound hammer test, which measured the surface hardness to estimate compressive strength. By using a spring-loaded hammer to hit the surface and measuring the rebound distance, engineers could quickly assess the quality of the concrete on site. So the next one is flexural strength test. Flexural strength test was conducted to determine the concrete ability to resist bending. Concrete beams were bent until they cracked, ensuring that the material could withstand the tensile force generated by the wind and other lateral loads, which is vital for the stability of the towers. So, given Kuala Lumpur tropical climate, we have to evaluate the concrete's resistance to environmental elements. The chloride ion penetration test measures the resistance to the chloride ions, which can cause steel reinforcement corrosion. These tests help protect the reinforcement steel, ensuring the structural longevity. So the next one is core testing. Core testing involves extracting cylindrical samples from the hardened concrete in the towers to assess inside concrete strength. This provided a direct evaluation of the concrete performance after curing, ensuring uniformity and compliance with design standards. Besides that, thermal analysis was conducted to monitor temperature variation during the curing process. By inserting thermocouples into the concrete, engineers could ensure the temperature remained within acceptable limits, preventing thermal cracking and maintaining the integrity of the structure. So at last, building the Petronas Twin Towers came with unique challenges that required special considerations to ensure the highest quality and performance of the concrete was used. Here are a few key points. The first one is high strength mix design. To achieve the necessary strength and durability, engineers use advanced concrete mix with special admixtures like super plasticizer and silica film. These additives improve the workability and long-term performance of the concrete, which was crucial for a tall structure. And the second is temperature control. Managing the temperature of the concrete during curing was critical to prevent thermal cracking. Engineers used techniques such as incorporating cold water and cooling aggregates to control the heat generated during the curing process, ensuring uniform strength development. So the last one is quality assurance / quality control, which is QA/QC program. So engineers implement a strict QA/QC program that included on-site batching facilities. This allowed them to closely monitoring the concrete mix and make real-time adjustments based on the test result. Regular testing and continuous monitoring ensure that they maintain the highest standards of the quality throughout the construction process.
I will highlight the architectural significance and concrete innovation of the Petronas Twin Towers. Firstly, the tower's design fused contemporary aesthetics with Islamic motifs, symbolizing Malaysia's cultures, identity, and aspirations. The concrete core integrates with steel and glass facades, provide essential supports, while the design incorporates local heritage and Islamic architectural elements, reflecting values of unity and stability. The concrete Concrete play vital roles. The reinforced core supports utilities and elevators, substantial foundations ensure stability on soft grounds, and a sky bridge built with high-strength concrete connect the tower on the 41st and 42nd floors. The superstructure used 3,000 tons of steel and 80,000 cubic meter of reinforced concrete with columns tapering as they rise. Innovation technologies include two-mass damper for stability, a ground-built sky bridge lift in two positions, and advanced facade systems with acoustics and temporary insulations. Superplastic scissors like Rio built 1000 enhance the workability and performance of the high-strength concrete. These features and technology makes the Petronas Twin Tower a symbol of engineering excellence and architectural ambition.
For the conclusion, we have know about the introduction of Petronas Twin Towers. We know about the detail of the material used in the concrete of the Petronas Twin Towers. We also know about the specific properties that were critical for the construction of Petronas Twin Tower. And we also learned about the production and construction process and the detail, the mixing, placing, curing and other construction technique used for the concrete in the building and challenge faced during the construction related to concrete and how they were overcome. We also know the testing of the concrete and the testing method used during the construction of Petronas Twin Tower. Finally, also the architectural significance and specific uses of concrete in the structure and innovative concrete technology employed in the building and the conclusion. That's all from our group. Thank you so much.